Hello friends, today we are discussing the radius of curvature in Cartesian form. As we know, the radius is nothing but the reciprocal of the curvature. The notation here we are using the rho. So radius of curvature in the Cartesian form, we are using the equation as rho is equal to, we have here 1 plus y1 square to the power 3 by 2 divided by y2. So here we are using the notation of y1 nothing but a dy by dx, differentiating y with respect to x, and this y2 notation we are using here as double derivative, d square y by dx square. So this is the formula we are using for the radius of curvature. Now we'll consider a simple example how to identify the radius of curvature. So first here we have show that the one example we'll consider now how to implement this formula. Show that the radius of curvature show that the of curvature radius of the curvature for the curve for the curve here we have the curve y is equal to a into log of secant x by a. Secant x by a is a into secant x by a. This we have to prove with the help of radius of curvature formula. So this is the question we have. We have to show that the radius of curvature for the given curve is a into secant x by a. So now we'll have the solution part of this. So now let us consider the solution now. Solution. So given that here, given that y is equal to a into log of secant x by a. So this is my given curve. I am calling as equation number 1. As you can see the radius of curvature, we have to differentiate the equation 1 with respect to x. So let me differentiate now. So here we have differentiate equation 1 with respect to x. Differentiate equation 1 with respect to x. So here I am writing the notation as y1, nothing but dy by dx. As we said, dy by dx we are taking as y1, which is equal to a is a constant. So derivative of log of secant is 1 by secant x by a, and the derivative of secant a we have here secant x by a into tan x by a into derivative of x by a is 1 by a into, we'll write 1 by a. Here you can observe a get cancelled and one secant term going to get cancelled. So now what is my y1 here? We have now, so y1 is equals to, y1 is equal to, we have only tan of x by a. So we got the first derivative of this as y1. Now I'll call the second equation. So now we have to find the second derivative also. So what I'll do, differentiate equation 2 with respect to x 1 second to find out the derivative. So this I am using the notation as y2, nothing but d square y by dx square. Derivative of tan x by a is, we have secant square x by a into derivative of x by a we have here as 1 by a. So this is my y2. So after getting the first derivative and the second derivative, we have to take now the radius of curvature. So let us consider the radius of curvature in the Cartesian form. Radius of curvature is given by what is the equation we have here? Rho is equal to 1 plus y1 square to the power 3 by 2 divided by y2. So after finding the first derivative and the second derivative, we have to substitute here. So what is my y1? Here we have tan of x by a. Let me take that thing here now. So rho is equals to, we have rho equals to 1 plus y1 square. y1 we have tan square into x by a, okay, whole to the power 3 by 2 into, we have here y2 as secant square x by a into 1 by a. Here I'll write the 1 by a. Okay, so now we'll simplify this. So in the trigonometry, we have the identity 1 plus tan square. We can take the value as 1 plus tan square, nothing but a secant square. So if we'll take 1 by a to the reciprocal, it comes as a only. So rho is equal to, we have here a into 1 plus tan square. We can rewrite as secant square x by a whole to the power 3 by 2 we have here. Denominator I am keeping as it is, that is secant square x by a. Secant square x by a. Here this square and this get cancelled. In the numerator, secant square whole to the power 3 by 2 we have get cancelled. So rho is equal to, here we have a into a cube, secant cube x by a, because 2 to get cancelled, here we'll have to the power 3 divided by secant square x by a. So square and cube here also get cancelled, will remains as 1. So therefore we can rewrite the radius of curvature rho is given by a into secant x by a. This we have to show that. So we got the same answer for the given curve. That is y is equal to a into log of secant x by a. Thank you.